Welcome to this brief introduction to powered fiber. Before we explore powered fiber, let us spend a minute showing how devices are installed traditionally. What is common with all types of devices, whether they are CCTV cameras, 5G microsites, public Wi-Fi access points, or any IoT device, that they all need power and data infrastructure. By far the best way to connect devices is by using Cat6 cables and harnessing the power of PoE, or power over Ethernet. But unfortunately, it is limited to only 100 meters. So, what happens when your devices are positioned beyond this 100-meter boundary? In such scenarios, you need to relocate your industrial switch within 100 meters of the devices. Furthermore, to power the relocated switch, you must supply it with 230 volts AC power. AC power needs electrical panels, breakers, and a PSU to convert to the 48 volts DC required by the switch. For redundancy in case of power failures, a local UPS is needed. AC cables will require dedicated civil works, including trenches and ducts. And then the optical fiber cable is needed, though thankfully, its installation is simpler and faster. Fiber cassettes are required at both ends. Micro ducts and micro trenching are often used. To house all these components, an outdoor cabinet with an IP65 rating is indispensable. Often these cabinets require active cooling systems, which is a potentially weak link due to its susceptibility to failure. Just consider the amount of effort and resources it takes to establish a connection for one location using these traditional methods. So what happens when you have multiple locations to consider? Like before, setting up AC cables would still require dedicated civil works. Additionally, separate trenches are required for the optical fiber cables. It is safe to say that the electrical infrastructure of AC cables and associated civil works is the most expensive, time-consuming, and heavily regulated, which in some cases render the full project unfeasible. Summing up the traditional method, building such a network infrastructure can be both costly and time-consuming. Fortunately, there is a less complicated, quicker, and simpler alternative available. Let me introduce you to the Hexatronic in-1 powered fiber solution, a momentous change in the realm of power and data infrastructure. To illustrate the Hexatronic in-1 solution, let us commence our exploration from where we concluded the traditional installation process. First, let us start by removing the no longer needed AC cables, panels, and associated accessories. With AC cables out, there is no longer a need for the accompanying civil work either. Now, let us substitute the fiber optic cables with the in-1 hybrid power and fiber cables. Fortunately, these hybrid cables are only slightly larger than the fiber-only cables, meaning they can, in most instances, utilize the same ducts if you had them already. With the new hybrid cables in place, our next step is to reconstruct the central node, now evolving into the hybrid distribution node HDN. Here are the HDN components. Initially, we added the power supply unit, which converts 230 volts AC into 110 volts DC. This output, being under the 120 volts DC threshold, eliminates the need for licensed electricians. Then, we introduce the hybrid optical distribution frame, which combines the DC power with fiber from the core switch into the hybrid in-1 cable. If needed, this node can also house a centralized UPS, replacing the multiple UPSs from our traditional setup. With the HDN now established, we can proceed to remove all the local PSUs and UPSs. This centralized approach streamlines our power management by replacing all local PSUs and UPSs, simplifying both installation and maintenance tasks. The final transformation sees the large outdoor cabinets replaced by the more compact in-1 hybrid access node. This unit, which is IP65 rated, is constructed from cast aluminum, allowing it to dissipate the heat generated by active components. This design also eliminates the need for active cooling, a weak link in our traditional setup as previously noted. The in-1 HANs regulates the DC voltage to a standard 48 volts DC. We now witness the complete power of the in-1 powered fiber solution. By choosing DC power over AC, we have created a one hybrid infrastructure that is not only more efficient and dependable, but also faster and easier to install. This ingenious solution truly revolutionizes the design and implementation of power and data infrastructure. As we wrap up this presentation, we will make a high-level comparison between the traditional approach to infrastructure installation and the Hexatronic way. Just by looking at the traditional way and the in-1 way side by side, one wonders why we had it this complicated for this long. Additional features of the in-one solution that we will not get into detail today are hybrid rings for redundancy, alarms for locating cable cuts and monitoring that can be integrated with your systems. And finally, a great reduction in CO2 emissions makes in-one not only a better technical solution but the right solution. To find out more, visit our page at hexatronic.com/in1. If you scroll down, you find detailed information and videos. Further down the page, you can book to visit our online showroom and get a full demo. We hope to hear from you soon. Please contact us at in1@hexatronic.com to find out more.